At any given second, a modern hospital is processing a constant, overwhelming torrent of critical patients and complex data. In emergency medicine, doctors operate by a harsh biological rule: time is tissue. Every passing minute spent trying to pinpoint a diagnosis directly correlates to irreversible tissue death for the patient on the table. To find those answers, a single radiologist often reviews hundreds, sometimes thousands, of dense medical scans in a standard shift. The sheer volume makes visual fatigue inevitable. Human diagnostic capability has simply hit a biological ceiling. Pushing past this limit requires technological intervention, not as a luxury, but as a critical necessity to keep patients alive. Bring that down to a localized level. Right now, a single physician is staring at a highly complex scan, fighting the clock to find a microscopic irregularity. An AI assistant instantly isolates microscopic anomalies on that image, flagging them before the human eye registers the contrast. It acts as a tireless parallel processor, analyzing pixels and presenting a calculated probability score to accelerate the clinical decision. Spotting a single irregular shape on a chest scan is impressive, but the true power of this system is the unseen underlying mechanics of how it learned to recognize that specific shape in the first place. To understand that, we have to pull out of the clinic and into the sprawling research laboratories where the data is actually processed. The intelligence of the system relies on neural networks. These are computing architectures modeled on the human brain, and they learn by ingesting millions of anonymized patient scans from all over the world. By simultaneously comparing thousands of images, the machine mathematically correlates microscopic pixel clusters to find hidden structural patterns of disease. This process strips away the subjective intuition of an individual doctor, building a statistically precise model derived purely from aggregate historical data. The predictive accuracy of this tool is a direct function of this scale. Without the macro data ocean, the specific AI-driven detection seen in the clinic would be impossible. Scientists are now taking this exact same pattern recognition power and aiming it far beyond medical imaging, applying it directly to massive datasets of chemical compounds. This visualization shows how the AI simulates millions of molecular interactions simultaneously, turning into an engine for rapid scientific discovery. Researchers use this high-speed sorting to identify viable new drug targets in a matter of days, bypassing years of manual trial and error. This technology compresses the timeline of pharmaceutical research, allowing laboratories to analyze potential treatments at a pace previously restricted by human observation. But the sterile precision of a data laboratory eventually collides with the messy, complex reality of human demographics. This chart tracks demographic data feeding an AI system. Trained predominantly on one specific group, its accuracy for underrepresented demographics severely degrades. Real world, this bias translates to systemic misdiagnoses for minority patients because their health histories were excluded. Correcting that blind spot requires gathering millions of intimate medical records, which forces a direct conflict between the system's need for data and a patient's fundamental right to privacy. Our technological capability has easily outrun our ethical frameworks. We have arrived at a precarious reality where our greatest medical tool is simultaneously our largest data vulnerability. Zooming out to a planetary scale, the sprawling, interconnected network of global healthcare data isn't a future concept. The infrastructure for this AI-driven era is already built, actively humming and processing our information today. The machine itself has no morality and no hidden agenda. It acts purely as a mathematical mirror, reflecting the exact data, biases, and priorities we feed into it. The future utility of these systems as life-saving tools depends on the ethical guardrails humanity builds today to govern the technology we've created.